Hi, this is Vince Sochi of LHP Engineering Solutions. I'm going to describe how you can manage data in rapid controls prototyping using LHP's Panthera tool suite. First, let me share a little about LHP. We develop embedded control solutions with 5 primary value streams: resources, software projects, hardware and platform solutions, data analytics, and training. Our platform products span the embedded development lifecycle from modeling to prototyping to testing to V&V to diagnostics. The software product I'm going to show you today is the LHP Panthera Rapid Controls Prototyping Suite, which is LHP's solution to model-based development on a real-time hardware platform. We do that by providing the MathWorks Simulink experience on National Instruments compact reel hardware. LHP Panthera has 4 key components. The block set is used to develop the control models. The FPGA toolkit bridges the control model to the real-time hardware. The runtime engine enables the model to be executed on the hardware. And the LHP Calibra calibration tool enables the operator to manipulate the control and the data in real time. The hardware product I will demonstrate today is the RCP evaluation kit, pictured here. You can see that it is made up of a National Instruments serial platform along with sensor and actuator interfaces, including throttle and load inputs, a throttle valve actuator, a tachometer, injector firing, and other I/O. I will be running the Pac-Man model on this hardware using LHP Panthera. Let's start in Matlab. Here you can launch your Simulink model, in this case Pac-Man, which is a closed-loop engine control real-time application. Now, we have some simulations here. If I go in to the periodic task, we have simulations for the sensors and actuators, for the engine model, and for the ECU. Now, as you dive in, you will see that these blocks that are indicated with stripes, those are the Panthera block set blocks. They integrate directly with the Simulink blocks into one compiled model. Now, if I go into my engine model, as you can see here, you would recognize that many of these components need to be prepared ahead of time. They need to be calibrated, so to speak, or tuned. You may want to change the data that you're using for a particular model. So what you can do is, right within Matlab, you could import data into your model. In this case, I want to change my engine plant model. I could import the data values from a prescribed pack of data into the model, and that would feed directly into the model. Now I'm going to build the model, and from Simulink, all you need to do is click the build button. Once you set the build up, we could watch in the diagnostic window as the model goes through. Now let's watch it load and deploy to the hardware. Panthera and Simulink are now working together to compile the model, create the software code, deploy it on the NI serial platform, integrate it with the FPGA to tie it to the real-time hardware, and then launch the application. Soon you're going to hear the engine model kick in and run the engine. Now I'm going to turn it down so it doesn't disrupt the presentation here. But as I switch over to LHP Calibra, which I'll load now, the LHP Calibra tool is our means of calibrating and working with the software within the operating model. So we'll prepare to monitor and control the application data in real time. Now first I need to load our A2L file. That is the file that gives us access to every signal in the Simulink model. So I'll pull that up, and as I get into Pac-Man, I'll find the A2L file and it will load. That will bring in access to every Simulink signal that I have within the model. Next, I'm going to have to load my calibration parameters that I've stored. They're the common ones the common signals that I want to monitor. So I'll again go into where my model is. I'll bring that up. I'll go into my calibration config and I'll say, here's my typical data management parameters. And they show up here on my sliders and on my signals. I'll start measurement. And you can see that as I adjust these levers on my device, I could watch my throttle position change. That's the one I'm moving here. I could watch my load change. There's the load, the red one going up and down. And you will see that the throttle valve command as well as the engine speed will follow accordingly. So the 4 sliders that you see here are parameters that you are monitoring on the strip chart. In this case, the throttle input, the load input, the throttle valve command, and the engine speed. I can move those around and the control adapts and responds. I can also adjust the model and other control parameters by poking data into it. Let's let this stabilize here. I have a low throttle position and a high load, so we should expect a very low engine speed. Now, if I switch that, give it a high throttle and a low load, you would expect a very high engine speed. And what you notice is a little bit of oscillation in the throttle valve command based on the stability of the control model. Now, should I get in here and start changing parameters? Let's see what happens when I change some, perhaps I change my prop control here. I'll change it from a 0.1 to a 0.01. Let's see what happens. And you can see the parameter gets pretty dirty, or the control gets pretty dirty. Now, that's real-time control of calibration parameters. I could just go back in, set them back up, get the control to stabilize, and it's back to where it was before. That allows me to manipulate the model in real time with control parameters. So LHP Panthera gives your engineer the ability to import data to the application, to monitor and manipulate the data in real-time operation. And finally, the other item I didn't show you yet is the fact that we have a data logger within Calibra. So you can even export data from Panthera to other tools, to log files, and archive and store them for whatever use you may have. Now, LHP Panthera Rapid Controls Prototyping Suite enables model-based design and data management on real-time hardware for practical application platforms. Thank you for your time today. Should you desire a personal demo or want to discuss the details of your application, please do not hesitate to contact us. We'd love to let the Panther prowl on your application.